This variation of parameters formula is going to require some trig identities to do. So the differential equation we have looks pretty simple. Y double prime plus 4y equals tangent of x, and the two homogeneous solutions are going to be cosine 2x and sine of 2x. What's going to be really bad, though, is the Wronskian might turn out kind of bad, and also our g of x, which is tangent of x, we're going to have times y2 and y1. So we're going to have tangent of x times cosine 2x somewhere. We're also going to have tangent of x times sine 2x somewhere. And we'll probably want to try and get that 2 out of the sine and cosine of 2x. And so here are some possible identities we can use. Not sure which ones I needed when I started the problem, so I just wrote down the ones that looked plausible. All right, so let's get started. Let's hope the Wronskian turns out somewhat nice. Let's go ahead and compute that. So the Wronskian of y1 and y2 equals determinant. All right, so we have cosine of 2x and sine 2x. Okay, derivative of cosine is going to be negative sine, but I have the 2x, so the chain rule pops out at 2. It ends up being negative 2 sine of 2x. Then over here, derivative of sine is positive cosine, and then we're going to pop out a 2 from the chain rule. So we get 2 cosine 2x. All right, if we compute that determinant, we get cosine 2x times 2 cosine 2x. That's 2 cosine squared. Fix that 2 there. Squared of 2x. Then I have minus, I have sine 2x times negative 2 sine 2x, so it's minus negative 2 sine squared of 2x. And thankfully, that actually ends up just being the number 2, because we end up with 2 cosine squared plus 2 sine squared. Cosine squared plus sine squared is 1, and so we just have 2 times 1. It's 2. All right, and I actually made this problem to do that. I kind of just fiddled around a little bit in Wolfram Alpha until I got something that I thought I could solve by hand that Wolfram Alpha solved for me. So let's go ahead and actually compute the particular solution. So let's go ahead and plug and chug here. So we have negative y1, so that's negative cosine 2x, so negative cosine of 2x. Okay, and then I've got integral. Got y2, so sine 2x, times tangent of x all over 2 dx. And I've got plus sine 2x times indefinite integral. What do we have here? Okay, so cosine 2x tangent of x all over 2 dx. Let me just separate that. All right, so let's take a look here. Equals negative cosine of 2x. All right, so indefinite integral. Let's take out the 1/2 while we're at it. Indefinite integral. Okay, I have sine 2x times tangent. Hopefully, if I use this trig identity, that's sine 2x equals 2 cosine x times sine x, it'll help me out. So I end up with, oh, that's funny, the 2's will cancel. So 2 cosine x times sine x. And then tangent I like to write in sines and cosines, so that's times sine x over cosine x dx. And I've got a plus, I'll take out that 2 as well, so we have sine 2x over 2 indefinite integral. All right, so I have 2 options here, so it'd be really nice, hopefully, that we cancel out the bottom of the tangent. The bottom of the tangent is cosine, so I'm going to probably use this one here. So I have cosine of 2x equals negative 1 plus 2 cosine squared of x. So I have negative 1 plus 2 cosine squared of x times sine of x times cosine of x dx. Right, I don't know this is going to work. I've done the problem, so I do, but I didn't know when I started, and really I'm just hoping that I get something that's somewhat easier to integrate, and the reason I'm changing these 2 x's to exchanging it for these trig identities with just x inside the sines and cosines is I'm hoping it cancels somewhat nice with the tangent function so I can actually integrate these things. Let's go ahead and keep going here. So this is negative cosine of 2x And I'm going to cancel out this 2 and this 2, so it's just gone. I also have cosine x over cosine x, so that's gone. So I just have sine squared, integral of sine squared of x dx. All right. Then from there, I have that 2 isn't going to just cancel out. It's not as nice. So I have sine of 2x over 2. And we got indefinite integral. So we have a -1. So indefinite integral, essentially negative tangent. I'll just write it again as negative sine of x over cosine x. Then I have my 2 times cosine squared. One of the cosine cancels, so I do have a plus 2 sine cosine. All of x. And that whole thing is dx right there. It looks like I'm not going to have enough room to finish this off completely, so we're going to go to the next page.